Morning again, everyone. So we're going to get started with, well, just one announcement, really. So this is the last day, actually, for this little survey. So I've got 8 answers so far, so that's kind of low, okay, but I appreciate the 8 people who took the time, actually, to provide feedback. And so that you know, most of the feedback that you provided, I can act upon it, okay? So some of it already made it to the GitHub. Some of it was shameful for me, like a HTTPS. Yes, we should have enabled the HTTPS like to get started with, okay? But that's the feedback for the software. Now, the feedback for the question themselves, etc., that's what I'm going to reprocess next time I iterate over the course, okay? So again, if you want to share your feedback, then this is the last day to do so. Please consider doing it. We are approaching the end. The end is near. So generally what happens is we have module M9, M10, we have time to wrap those nicely. And then it depends on the semester. Some semesters, I have like one extra session, where this semester, what I'm going to do if I have it is probably recursion, okay? Some semester we're a little bit tighter, so it depends on the level of interaction during the lecture, stuff like that, okay? So consider M9 the last, I would say, new module, new content module in the semester. M10 will be an extension of it. So in M9, we are going to start working with arrays. M10, we are going to just generalize what we've learned to do with arrays to many dimensional arrays. And that's it, okay? So that up to M10 is going to form what you should be expecting to study for the final exam, okay? So we have 2 more IEs, IE07, IE09, okay? And then we have the final exam. So that's really the last stretch. Make sure that you stay on top of it, okay? All right, so let's talk a little bit about arrays. Basic array means 2 things actually. Basic array means one-dimensional arrays. So a one-dimensional array is what is otherwise known in other topics, in other discipline as a vector, right? So you already know the idea of a vector, okay? So that's the first thing about basic arrays. The second thing about basic arrays is that Java has different types of arrays. What we are going to study in COP2512 are the most rudimentary ones. And why do we even study those, since there is something better afterward that we study in COP2513? Well, because the ones that we are going to study in this module, they are like everywhere. They are in every programming language, including the C programming language that you guys are going to deal with in not so long of a time, okay? So we want to cover those basic array because they're still around, they're still there in scripting language and whatnot. At the same time, I want to give you a heads up. If you come from Python and you're looking at this and you say, I miss my Python, I really miss my arrays that resize themselves and do all that stuff for me without having to worry. Don't worry, we are going to get there in Java as well. There are classes that allow us to do that in Java as well. The reading assignment for this module, chapter 07, so you know how this works. These are the learning outcomes for the chapter 7. So as you can tell, this one is really going to be new. Okay, there's almost nothing green. The arrays is a topic that I've not even tried to introduce superficially to you during module 1 to 3 and after that, okay? So I kind of saved it for the end. Why? Not because it's hard, just because at some point you have to be careful about not trying to cover the entire course in the first 5 weeks and then recover it, okay? There is already a redundancy in the course built in, but there are some topics that were not strictly necessary to get started learning how to program. That's one of them, okay? We have been doing just fine until now, but to be true, we have been avoiding a certain category of problems. So now we're going to be able to deal with them. So like usual, I'm not going to go in the detail. This is just to give you like a color overview of the module. A lot of stuff covered in the lecture. I try to leave very little for the reading assignment, and actually some of those things are also going to be covered in the lecture. I kind of change it at the last minute. So the goal is to really expose you to everything about basic Java arrays in this module and do it mostly during the lectures, okay? As far as learning activities, this is a full house module. So PEs, PQs, you know the drill, GQs, coding bat exercise. As the last time we're going to use coding bat. So module 10, by the way, module 10 is not going to have a lot. Module 10 is going to have maybe PQs, practice quiz, okay? It's going to have maybe, some PEs for you to apply it. But the idea of module 10 is nothing should be graded in module 10. So that we finish the semester, like right before the final, we finish the semester with you not having so much to worry about completing, the small exercises that are there for the very last module, but you can start reviewing for your final if you need time to do so, okay? So this is going to be probably our last full house module in the whole semester. Here are the recommended practice exercises, the graded exercise on coding bat. So does some of you notice that the last batch of coding bat exercise, there was a very nice one in the batch. So if you haven't tried it yet, go for it. But there is one that is actually a very nice level of difficulty for this class. When I say a very nice level of difficulty, what I mean is horrible, okay? That means that it's actually very challenging. All right, but the bottom line is come to office hours, get help, okay? And you are going to get like a sort of overview of what you are expected to be able to do after the end of this class. So not maybe right, after the end of the class. I'm not going to write a final exam that is going to be like that exercise, okay, that coding back exercise. However, after you have had time to digest for like maybe a few weeks, what you learn with me and practice it in another class, you should be up to that level. So we're talking about a few weeks into COP2513. You look back at that exercise and, it's still challenging. I'm not going to lie, but it's going to be more feasible. Okay. But in the meantime, yes, I assigned you a little bit of a toughie there, but come to office hours to get help so we can help you through that. All right. And it's a good overall review of everything. In here, this one, if I remember correctly, is going to be a little challenging as well. I'm not sure, I would have to double check. But the others are really, really feasible. Okay, so let's talk about arrays. Why do we need to use arrays to add pretty much another data type? Actually, not just one data type. We're going to add a load of data types to Java. Like with one concept, suddenly we pretty much multiply all of the data types available in Java by 2. How do we do that? Simple. You have an int. An int is an integer, right? A small integer. Okay. I can now create an array of int. An array of int just means a vector of int, multiple int, each with their own separate value, so multiple int variable, all stored in a vector that we can access by, looking at the position in the vector of each of those, okay? So if I have an int data type, I can create an array of int. What if I have a double data type in Java, which I do? I can create an array of double. So any data type that is a valid Java data type, I can take it and say, well, now I want an array of those guys. So that works with all the primitive data types. Okay, long, float, double, int, short, etc. Okay, that works also with a reference data type. So as soon as we say reference data type, it opens the door to an infinity of data types, okay? Because every time we're going to write one of our classes in COP2513, then we're going to add pretty much a class, we're going to add something that we can use as a data type in Java. So now the sky's the limit. We can have an array of everything, an array of scanners. I'm not sure what that would be useful for, but I mean, theoretically, we can do that. An array of string. Yeah, we're going to play with those at the end of this module. So an array of anything that is actually a class. And then I told you that, so it's more than just multiplying by 2 all of the available data types. Actually, I messed that up because now that we have these rules in place, well, an array of int is kind of a new data type, right? So what did I just tell you? That you can take any valid data type and you can make an array of them. So if I have an int data type, I can make an array of int, my vector. If I have an array of int values, a vector of int as a valid data type, then I can say I want an array of those. So my first element of the array will be an entire vector. My second element of the array will be an entire vector, and so on, so forth. How do we call those things? Matrices, right? So now I have an array of arrays of int values, and I can keep going. So that's why module 10, for us here, we're going to just look at an array of int, an array of double, an array of string, something simple like that in this module. Next module, we start talking about having an array of an array of an array of an array of int. That's a multi-dimensional matrix. That's all this is, okay? So we can keep generalizing like that ad nauseum. So until we're sick of it, okay? So that's it, and that's it for every language. Generally, this is how we represent a matrix in any language. We say it's an array where every element of the array is itself an array. So my first array represents the rows, and each row is represented by a vector where each element inside of it is a column. So rewinding a little backward to the most basic example, an array of int, for example, here's a little program that I need to write. Read 5 integers, 5 ints, compute their average, and find out how many are above the average. So the problem with this is that for me to decide if the value that you give me right now is above the average, I need to first have read all of the value from you and computed that average. Once I have read every value from you and I computed the average, then what I need to do is I need to go back and revisit the first value that you gave me, the second, the third, etc., and compare it to the average to know if I need to keep it or not, okay? Well, so that means that I need to store every single value that you are giving me, which we have not done until now. We have done variants of that, like out of the bazoo, but the bottom line is that we always read a value from the user, did something with it, and then use the same variable to read the next value. So the first one was gone, the second one was there, and then I trash it, read the third value, and so on and so forth, right? Now we're going to store. So an array is a good way to store that kind of stuff. All right, let's take a look first at how we are going to do that without an array. And I hope that I'll make you enough stomach sick that you will never want to do that ever again. So we need a scanner. And then let's say that we bound the problem. We say there's going to be 5 values from the user. I know that for sure. This is part of my requirements, okay, my constraints. So int data 1, data 2, data 3, data 4, data 5. Okay, I have 5 variables. I read 5 int. So data 1 equal s.nextInt, cut and paste, cut and paste, cut and paste, cut and paste. And then the sum of all the variables, here we are, sum equal data 1 plus everything up to data 5. The average or the mean, sum divided by 5.0. Okay, easy peasy, nothing complicated in this program. And then I need to count how many of those values were above average. Well, I stored them all. They are here, data 1, data 2, data 3, etc. So I say, here's my counter, n equals 0, okay? If data 1 is above the average, increment the counter. Well, now I need to look at data 2, data 3, data 4, data 5. So I have 5 if statements. At the end, system.out.println, n, whatever my counter is, n of those values are above the average that I calculated of AVG. Okay. Well, we made it work. And we don't have like the shadow of an array in this program. So we can do without arrays, right? Well, we can kind of do without arrays, yes. But then if the requirement changes, change, we're going to get maybe in trouble. New requirement. Oh, it works for 5 values from the user. That's awesome. So now that we have like a prototype, let's make it a production system. Now the users are going to provide 100 values. Well, that's going to be a lot of cut and paste. Okay, I'm going to declare all those variables, data 1, 2 up to data 100, and then I'm going to cut and paste all those steps where I read. Where's my loop? I want to cut and paste all those if. I cannot use a loop because the loop is lacking something essential. The loop is lacking a way to tell me the first time I iterate, I want to look at this variable. And the second time I iterate, I want to look at this variable. If I could do this, I could put one of those statements in a loop and change the name of the variable that I use to store the value that I read every time. I could put a loop around that if statement and change the name of the variable I want to look at every time compared to the average and increment my counter. So I'm stuck. I have to do cut and paste, but I can still make it work. I'm not fired yet. And then new requirement. Well, it works for 5. That was our prototype. It works for 100. We have been having that in production for a while. It's no problem. So you know what would be nice is that the user at the beginning of the work session with the program, the user tells us how many numbers they want to enter. And then I cannot make it work anymore. Okay, I cannot make it work anymore because pretty much what you are telling me is I'm going to write this code, I'm going to compile it. And once it runs, the user is going to tell me how many variables I need here. No deal. I cannot go back and rewrite the code. Okay. So that's actually the simplest example I could come up with to show you a case, like a problem, a very simple problem, once again, where you cannot get it done without arrays. So that's the example we're going to use here to introduce arrays. So we don't introduce arrays just because we don't like the variable data1, data2, data3, and we want to name them elsewhere. No, differently, I mean. We introduce arrays because we want to use loops. That's really the primary motivation. And to be able to use loops, I need to be able to access a bunch of variables, like data1, data2, but I need to be able to access them with a sort of index, right? And that's where the array comes in. So my scanner is the same. The size, which is the number of values the user is going to input, now it's a variable, which means that right now it's hard-coded, okay? But later, if I decide to do so, I can do system.add.println. How many value do you want to enter? And then create a scanner, read a value from scanner, and then put it inside size. After that, here comes the new syntax. So the new syntax for arrays, we encountered it one time because I did this one example where we did a quick preview of array just to show you what happens with reference data types when you pass them to methods, right? So you've seen already that we use the square brackets. Okay, this is part of the syntax for array. To declare a variable named data that is an array of int, I can write it like that. Int data pair of square bracket, nothing in between the square bracket. That just reads, data is an array of int. So the data type here is int empty square bracket. That's the name of the data type. It's a new type of names for data types. Okay, it's composed of another data type name plus the empty square bracket. That's it. Arrays are objects. So this is why we're going to dig more and more into reference variable and stuff like that. Arrays are objects, so they're not primitive data types. It's not because I declare an array of int like that I'm going to actually get an array of int. When I write int data empty square bracket, what I actually get is a reference variable named data. And that reference variable, no matter how big the array will be, okay? So maybe later I'm going to have an array with 1 million elements. This array is going to be huge. It's going to take 1 gigabyte of memory. I don't care. Right now, the data variable is just a reference holding variable. So it's this big, like 64-bit, 32-bit, depending on the architecture, I don't remember. But it's going to hold the memory address, where the actual array, the object of type array of int, will be created and stored, okay? So this is just like the tip of the iceberg, right? This is just like my little variable that contains the address where to find the actual array. And this is how I create an array of a given size. The new keyword, so every time I create object, almost every time I create objects, okay, we're going to come back to that, but every time I create objects, asterisk, asterisk, I use a keyword new. So here, new what? Do I want a scanner? Do I want what else do we do? A string? What is a class name? Well, it's a little bit different here. I don't have a class name that looks like the usual class names. The name of the data type is int square bracket, which means array of int. And that is actually a class in Java. It's just the notation for the class is unlike any other class that we have dealt with until now. And between the square bracket, finally, I'm going to use the square brackets for something. Between the square brackets, the moment you say, go and create me an array, Java is going to want to know how big. And again, if you come from Python, this is weird. JavaScript is the same. I think JavaScript, Python, they have like variable size arrays. You don't have to bother really with the size of an array. Just keep shoving stuff into it. And when That's it, actually. You just shove stuff into it. You don't even have to worry that it's going to get overfull or something like that, right? Well, Java, a bit different, at least with the basic arrays. C, the C programming language, also going to be very different compared to Python and stuff, and it's going to worry about a lot more details. So one of those details is the size. How many elements do you want in the array? So when I say int data square bracket, so let's say that this is my variable data, okay? This is my variable data. It's allocated in the stack, in the activation record for whatever method I'm running right now. And then I create with a new keyword somewhere else in memory, an area called the heap. I create an array of int value, so a vector of int variable. Each slot is an int variable. How many do I want? Well, in this case, size. So instead of size, you can put whatever expression you want, right? But it needs to resolve actually at, does this need to resolve at runtime? Okay, I need to look that up, sorry. I've been working with another language lately and I'm kind of like overlapping the two in my head. So size for now, we're going to say it needs to be fixed, okay? Computable at computation time. And I'll correct that if I say something stupid right now. But I specify here an expression. This expression is evaluated. This is 5. I create my array of 1, 2, 3, 4, 5 int variables, pretty much. My vector of 5 int. And that variable here, reference that array. And that's it. That's what we did here. Now, how do we use the array? Again, square bracket notation. So for int equals 0, int I, equals 0, I lesser than size, I plus plus, counter control loop. So with arrays, we're going to deal a lot with counter control loops, okay? So I want to go in my counter I want to go from 0 to size minus 1. If you say I lesser than size, right, you remember that means size minus 1 included, size not included. Okay, so why do I want to go 0, 1, 2, 3, 4? Because I'm going to use this counter to actually access each of the variables that are in my array, each of the slots that are in my vector. How many slots do I have? 5 slots. I'm going to call the first one data index 0, then data index 1, 2, 3, and 4. That's it. I covered my 5 slots. So what I do to access one specific element in the array, data index I. Again, square bracket notation. So I use the square bracket notation for 3 different things, okay? Most students are okay with that. Like once in a while, I get a student that get hooked onto that and kind of a little confused. So I'm going to go ahead and draw your attention to it, okay? Here, the empty square bracket, they're just meant to say data is of type array of int. Here, it doesn't have the same meaning. Here, it's to mean I want to create a new array of int with a specified size. And here, I'm not trying to say that data is an array of int or I want to create an array of int of a specified size I. No, it's a third meaning. I want to use the reference variable data, access the array that it refers to, and inside that array, I want to access the element at index I, whatever I is. So 0, 1, 2, 3, 4 in our example, okay? So 3 different locations is the syntax of the language, declaration of a variable, creation of an array, access to one element, and these are the 3 different ways that we use the same square bracket syntax. So at least it's consistent, but like I said, once in a while I get a student that tell me, but what does that mean, square bracket? And the answer is like, where? What are you looking at? Okay, tell me what you're looking at, I'll tell you what they mean by square bracket. All right, so what are we doing here? We are going to access data index 0 and store into it the result of reading something from the user. Easy enough. Then next iteration, data index 1, so the next element in the array, read something, put it into it. So I use data index I as I would use any int variable. If I have an array of int, every time I access one of those slots in the array, I can use that just like I would use any int variable. If I have an array of double, I can use every slot in the array like I would use any double variable. So I can assign values to those slots. I can even display on the screen, we're going to see that here, display on the screen what's in the slot. I can use the content of the slot in an expression, in a formula, etc. They are just a bunch of variables. So once you understand that, suddenly you can see how much stuff you can do with arrays, right? So keep going. Read 5 numbers total. Put them in every slot of my array. And then in sum equals 0, I'm going to compute the sum of all the elements. Again, a loop. Loops and array, they really go hand in hand together, obviously, right? So instead of doing like all of those addition one by one, I say, okay, let me iterate again over every element of the array. So every time I want to iterate over every element of my array here, okay, I use a counter control loop. And I use a variable that's going to be an index. So generally we use I, but you can use whatever you want. An index that's going to tell me, okay, I'm looking at element 0, then 1, then 2, then 3, and 4. And that's going to become a pattern, right? So I iterate over every element of the array again, like I did here. And what I do is I add to the sum variable whatever is in the first slot. Then I add whatever is in the second slot. So I make the sum of all the elements of my vector. And once I have the sum, I compute the average by dividing it by the size. I use explicit typecasting here to make sure that I get something that is a double value at the end. And then last pass, so I made 3 passes on that array, okay? 1 pass to fill it with that data, a second pass to read the data and sum it all up, and now a third pass where I'm going to still use the variable I as an index equal to 0, lesser than size, I++. So counter control loop again to go over every element of the array. And what I do is I look at element index I, and I say, well, if whatever element I'm looking at right now is greater than AVG, then increment the counter n. So n is going to tell me how many of them are above average, just like in the previous version, right? But this time I use a loop to say, are you above average? Yes, okay. N++. Are you above average? No. Okay, I don't increment n, etc. Okay? And then system.outPrintln, well, that part, there's nothing new. I just display the results that I found so far. Okay. So all of that because we want to actually do something very simple, right? But the array makes it scalable. Like I said at the beginning, you don't like 5, put a 10 here. You want 1,000,000, put 1,000,000 here. You want the user to tell you the number? Ask them, put it in size, and then everything works the same way. So the code has become very sizable suddenly. All right. So if you want to visualize in your head an array, or like you need to draw some diagram on paper, etc., I recommend you do it like that. Okay, this is a no-lie type of diagram, meaning that it's not too much of an oversimplification of what's happening actually in memory. Okay, the only thing that's missing here is I should say that this variable is going to be on the stack, this object is going to be on the heap. But besides that little detail, of implementation, it shows that when you declare a variable called, for example, mylist, and you say, hey, my list is going to be an array of double. There we go. This is your reference variable containing a reference. After you create the array, it's going to contain a reference to access that array. The array is going to be a vector, a continuous vector of doubles in this case. So we have a size of 3, 6, 9, 10 here. And then we access each element with that syntax. The name of the reference variable, square bracket, the index between square bracket, and etc. There is almost nothing that can go wrong with this, except if you forget that the first element is 0, and you start saying, hey, I'm going to look at element index 1. That should be the first one, right? Now, always start counting at 0 in computing. And then the second thing that can go wrong is, how many elements do I have? 10? Okay, so the first element is at index, oh, wait a minute, 0, I remember. And the last element is at index 10. Wrong. The last element is always index minus 1 to the number of elements. So 0, 1, 2, 3, 4 for 5 elements, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 for 10 elements. Okay, you start at 0, so you're going to have like one more there. Okay, these are the only thing that can go wrong with arrays. So let's talk about syntax a little bit. So I already kind of used the syntax, I went with it. didn't ask myself a lot of questions about that. There's not much to say except that in Java, you have two different syntaxes actually to declare a reference variable meant to hold a reference to an object of type array of something. So this is the one I've used in the previous slide. This is the one that you should actually avoid. This is like the legacy one. When you do C programming, you're going to use that notation where we put the type of the element that are going to be inside the array, followed by the name of the reference variable to the array, followed by the symbol that means, hey, I want an array of double. I just don't want one double. If I wrote only this, double my list, I get one double. And with this, I get an array. Okay. This is still accepted by Java. I don't know if they are going to be one day, rejecting it, but this has been on the list of things, to avoid for a while now. This is kind of a legacy notation. People nowadays prefer in modern programming language to use that notation because it's easier to read left to right and know what you're talking about. Double, square bracket, array of double. So that's it. The data type is here. I don't have to look, before and after the name of the variable, and then give me the name of the variable here, my list, and we're good. Okay. So double square bracket, my list. That's the one that you should be using from now on. And then what we've seen is when you declare a variable like that, you don't get much. You really only get your reference variable, and you don't have an array yet. So we need to create the array, and this time there's only one syntax, new, the data type that you use for each element of the array. So by the way, all the elements of an array have the same data type. Python programmer anywhere? You guys can shove whatever you want in your array, right? My first element is going to be an int. My second element is going to be a double. My third element will be a string. My fourth element will be a picture. That's no problem in Python. In Java, yeah, it's a problem. What I'm showing you here is that when you declare, it's always my list is a reference variable meant to hold a reference to an object of class, array of double. An array of double contains only double data type value, okay? So here, new, the data type for the element, how many elements you want, like we just did, and that's it, okay? So you can do it in one step, which is what we have done on the slide. So declare your variable, create the object, put the reference to the object in the reference variable, kind of like what we did with the scanner, right? It was almost always one line. But there's nothing that prevents you from breaking it down into lines. Declare the variable, do not initialize it. Ooh. And then assign to the variable later on a reference to an array that you're creating on that line. Okay, so we can go either way, no problem. And this is mostly stuff that we have already covered, okay, with regular variables, I mean. But now we are learning to do it with array. Two more remarks, and then we move to the next slide. That size here, it's fixed. So that's another difference with other programming language like JavaScript, Python, and etc. Once you say I want an array of 10 elements, Java goes into the heap, that area of memory where objects are created, carves out a chunk of memory big enough to contain 10 int values, and that's it. It's never going to grow. It's never going to shrink. It's what it is. It's big enough for 10. And now I put the reference in the variable. So you have to be careful about how you size things. One of the first things we're going to learn to do with arrays, we're going to learn to create arrays of fixed size because we don't have a choice yet in Java. And then we're going to ask ourselves, but what happens if I really don't know what the user is going to type or how much they're going to give me, right? I don't know if they're going to give me 5 value or 10 value. So very soon we are going to introduce the concept of, I don't have resizable arrays in Java yet, but even with those good old, old-fashioned fixed size arrays, what I could do is I could say, okay, here's my variable, my list. It refers to an array of 10 slots. And you keep giving me data. And I show the data in the array. And when I run out of room, what can I do? I can create another array that's going to have 20 slots. So the double of what I had, right? I copy the first 10 slots from the original array into the new array. And then I ask you, okay, give me more data. I make my variable reference the new array, and I keep adding data until I fill up those 20 slots. And then guess what? Create a new array, 40 slots, put my variable to refer to this array, copy the old data, and start asking you more data, fill in the blanks again. So we can do things like that by hand. Do you want to do that by hand, like when you write a piece of code? Hell no, exactly. You don't want to have to do that by hand. But the good side effect of doing it by hand, for one class, is that once you do that, then you are going to be more comfortable with memory allocation, controlling memory allocation. You are going to be more comfortable with arrays. And when you have to deal with a language like, again, C, for example, where you don't have a choice, you don't have resizable arrays out of the box, then you will know how to handle those kind of situations. Okay, so we make a little detour here through resizing our arrays ourselves, and then as soon as possible, I'm going to use a class called ArrayList in Java, and ArrayLists are going to be pretty much like what we are used to in other programming language. If you took Python or JavaScript, this is going to be like fantastic. It resizes automatically, does everything automatically. We don't have to worry about anything. But right now, we're still learning. What's the default value? So let's rewind. What's the default value of, for example, if I declare an int x and I don't initialize it in my main? What is the default value inside of x? You guys remember? 1, okay. Any other suggestion? Oh, -1, sorry. So -1, I'll say 1. What else? 0. Now, so if it's a local variable inside a method, right? Like I said, we declare int x in the main. If it's a local variable inside a method, remember all that stuff we talked about last lecture about the stack and allocating in activation record and stuff like that, okay? Take a quick look just at that part of the video again, or do the reading assignment, on that part. It's really important because it tells you the story of how you cannot predict what's going to be actually inside those variables. But now when you create an array is an object, right? So everything I talked about during last lecture was for local variables that are in the stack, the program execution stack. Now, everything that's going to happen on the heap, every object I create, those are going to be initialized by default for us. So it could be -1, it could be 1, could be any arbitrary value. The default choice in Java is 0. So if you have an array of any numeric data type, you're going to get 0 or .0.0 inside each element of your array for free. You don't have to worry about it. So I create my array here, new double 10. I know that there's 10 zeros, 0.0 inside each element of the array. If it's not a numeric data type, like if it's an array of booleans, you can do arrays of whatever you want. So you need 10 values that are true, false, create an array of 10 booleans. Well, by default, it's going to be false. If it's a character, it's going to be character index 0 in the Unicode table. Again, the idea being, 0, false. These are going to be always the default values for those elements inside the arrays, okay? So things are a little different. When you initialize objects, you're guaranteed to have default values in there. Think of the object as a fancy tool to use, okay? When you declare just regular local variable in a method, you're not guaranteed jack. So now that we have a reference variable meant to hold a reference to an object of type array of something, and we have somewhere else in memory that array object, array of int, array of double, array of 10 chars, whatever you can think of, okay? We can start using that reference variable to access the element of the array. We've done that already using the square bracket notation. Or you can just use the name of the reference variable to do operation on the whole array. For example, if your variable is mylist from the previous example, mylist.length, no parentheses, by the way, mylist.length, as you may guess, is going to tell you how many elements you have in that array. So you use a reference variable, you call a method or an attribute of the reference variable. I'm going to go back on this in a second, and you get information about the entire array. So why don't we have parentheses here after length? We have parentheses when we call a method, okay? So for example, scanner s equal new scanner system.in, and then s.nextInt. parenthesis. I call the method nextInt on the object referred to by the reference variable s. Okay. Here, this is not a method. It's what we call an attribute. We have not started playing with attribute yet. We're not going to start really doing so seriously until COP2513. But basically, a method, it's just like a piece of code that is inside an object, right? You can call it, execute it on that object. Well, an attribute is like a variable that's hiding inside the object. So when you write mylist.length, you use the mylist reference variable, you follow the reference, you find the object of class, let's say array of int, of 10 int, and then you check inside that object for a variable named length. And that variable is guaranteed to always contain the number of elements in the object. So it's not calling a method, it's just accessing a variable inside your object. If I remember correctly, this is almost the first time we've done that. Exception to that, math.py, math.e, but these were constant. Well, we can have constants inside objects. We can have variables inside object. We can have method inside object. And everything that I just said about object is true also with classes. So that's more COP2513, okay? All right, but that's convenient for us to know that we can write, mylist.length and get access to that value so that we don't have to track separately in another variable of our own the size of the array at all time. Accessing the array element, we're going to go fast over that slide because I pretty much talked about everything concerning that, when we were dealing with our example. So here's the syntax: mylist index 0, mylist index 1, up to 9 if we have 10 elements. You can use those everywhere you would use a variable of that data type. So if your array contains doubles, every time you can use a double, you can use, every time you can use a double value, you could use mylist index, whatever. But just make sure that those index are correct. Okay. What happens if I say mylist index -1? I get the program to crash at runtime, and it spits out on the screen an exception telling me something like blah, 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 array index out of bound exception. Well, that exception kind of makes sense. Once you see it once, you understand what it means. It's going to be one that you guys are going to catch up on very fast. That means that the -1 was out of the acceptable boundaries, the acceptable range for an index value. What is the acceptable range of index for my list? Well, if I declared it like in the previous slide, an array of, I don't remember if it was int or double, I keep changing back, but let's say an array of 10 doubles, right? Then 0 to 9 is the range of acceptable indexes, inclusive. -1 is out of here, forget it. 10 is out of there, forget it. Most of the time, that's what goes wrong. You write code in coding bat, you start seeing those exceptions popping up in your test, okay? That means that you went probably one too far after the end of the array. That's going to be something that almost all of you, I'm pretty sure almost all of you are going to commit that bug at some point, okay? So be on the lookout for that. Review the logic of your index, your counter control loop. Is there any possibility for the index I that you are using to be out of that range? If so, correct your code, okay? All right, and that's kind of like a little self-contained introduction to arrays. It contains pretty much all the syntax that we need. So now the question is, what are we going to do with arrays? How are we going to use it? So what I'm going to go over are patterns. Remember module 1 to 3, when I told you how do you come up with the idea of I'm going to implement this particular micro feature, by using this piece of code in my mind. How do you come up with a connection between a piece of code and a small feature that you identified in the requirement? Well, you do some sort of pattern matching, right? Constantly. Is that little requirement implementable as one of the building blocks that I learned? There are 6 of them, okay? So I can check that real quick. No? Okay. Is it something that I've seen, like a counter control loop, a sentinel control loop? Is that something that I've done in an exercise, like summing all the values in an array like we just saw? Well, that's exactly what we're going to look at. We're going to look at little tidbits of programs that, and it's not an exhaustive list of everything you can do with an array, but they are going to show you what has a base operation that you can do on an array. so that you may then recognize in requirements, hey, this looks like this one time in Bandcamp where I initialize an array. Yes, it does. So now remember this and adapt it, modify it to what the requirement exactly wants you to do, okay? So that's the kind of stuff we're talking about here. So let's take a look at those traditional, typical tasks that we want to do on arrays. Well, we want to initialize them. We want to put values in those arrays, okay? So this is kind of like what we've done in the first example at the beginning of the lecture. We declare mylist, a reference variable meant to hold a reference to an object of type array of int. We create a new array of 5 int value, put the reference to that new array into the variable mylist, create a scanner, same like logic here, like reference variable, blah, blah, blah. Display to the user, I want you to enter how many elements did I have in my array? Well, don't worry, I can ask the array. How many elements do you have? Mylist.length. So that's going to be a mylist.length, and that's going to be a 5, okay? Because I created the array of size 5 at the beginning. So enter 5 values. And then, again, like what I did at the beginning, a loop, and keep reading a value, keep putting it in the next element, in the next slot in the array. So what characterizes these is the fact that we create an array. By default, it's filled up with zeros, or if it's a Boolean array, false, okay? Well, it's not good enough for me. If I wanted an array full of zeros, that's it. I don't need any of this. If I want specific values, then I'm going to have to pull them from somewhere, in this case, the user, and I'm going to put them one by one in the array. One by one is the array, that's tedious, so I use a loop, okay? If I don't want to read data from the user, but I want to declare and create an array of 5 integers, and then I want to fill it up with 5 random integers between, let's say, 0 and 99 included. Well, same logic. Counter control loop, iterate over the index of all the elements in my array. So I equals 0, I lesser than my list.length I plus plus. Same exact thing here. So this is going to become like a recipe pretty much that you're going to memorize, right? And then my list index I, what do I do on each element of the array? I assign to it, well, the conversion to an int of math.random times 100. And this actually is total BS because this is missing like a parentheses here, I think. So I'll check that during lunch and upload the corrected version because int cast of math.random is going to give us 0 every time, so that's not very random. All right. What else? Well, there is another way to initialize array. So now we're talking syntax, okay? We're talking little details, not concepts or anything like that. So when I declare a reference variable mylist, meant to hold the reference to an object of class array of double in this case, I can actually use a notation here that looks like a literal notation for arrays. Like a literal string is when I put double quotes and I put the text, the data of my string like this. A literal int is when I put the value of the int like that hard-coded in my program. Well, here, I'm not even saying I want to create an object of class array of double. I'm not using a loop to iterate over that object and put values in there. I'm just saying open curly brace, close curly brace. So watch out, that doesn't mean a block. Okay, yes, we have been using curly braces to define blocks in Java since day one. Okay, this is called an initializer, an array initializer block. It's a very special type of block. I cannot have code inside of it. The only thing I can have inside of it is a list of values separated by comma. What are the rules for the arrays? Fixed size. So how many values you put here? 1, 2, 3, 4. That's going to be the size of my array. I cannot do something like, for example, 1, 2, dot, 9. Like as a way to say, I want 1, 2, 3, 4, 5, 6, 7, 8, 9. No. There's no ellipses. There's no dot notation. You have to give me all of the values you want separated by comma, and that's going to determine the size of the array. And then the second rule of arrays is all elements are the same data type. So if this is an array of double elements, This better be a double. Or it better be something that Java can implicitly convert to a double. This better be a double. This better be a double. This better be a double. You get the idea. Okay? So that notation is like a shortcut. The same way that when you use double quotes to initialize a variable, right? Java creates an object behind the scenes. Well, behind the scenes here, Java is going to also create an object of class array of 4 double. And then it's going to fill in the values for us. And that's a lot more convenient than if I have to write stuff like that, which is what I would have to do if I want to initialize an array to specific values. I would have to declare the reference variable, create the array of size 4, and then say, okay, I want to put that value inside the first element, that value inside the second element, and so on, so forth. So it's a very convenient notation, okay? You don't have to do everything. Well, sorry, you do have to do everything on the same line when you use it. So, like 2 slides ago, I was telling you, you can write double square bracket my list, semicolon, and then my list equal new double index 4, right? Size 4. Yeah, you can break down every declaration and initialization except that one. So that one way to think about it is that little convenient notation. It's really a sore exception in the Java language. It can be used only that way in that context. You have very little degrees of freedom. Okay, it's not one of those things that we're going to generalize to a bunch of stuff. So that means that if I wanted to write, and I think I have the example here, if I wanted to write things like this, it makes sense. You know, when you learn that notation, it makes sense. So let me draw your attention to the fact that even though it makes sense, and if you use your common sense, you might be tempted to write stuff like that, you cannot use that curly brace block notation, except on the very line where you declare your reference variable to the array. It's only going to work there. So if I say double square bracket my list, declare a reference variable named my list. Sorry, this is a little bit low. I'll try to avoid that. My list is a reference variable to an object of class double array. Okay, I haven't created the object yet. And then I try to say my list equals and the same syntax than here. No. Now, since you declare my list like that, what you have to do is you have to create by hand the array, assign the reference to my list, and then assign each value of my list independently. No choice. So yeah, convenient notation, but usable, you know, like only once in a blue moon. So be careful about that. What else? So that's it for initialization of arrays. The second thing that we do all the time with arrays, like literally you can learn those patterns by heart if you're still struggling with the logic of coming up with your own code, right? And that will serve you well. Apply the same operation to every element. What does that mean? I want to display every element in my array, or I want to add 1 to every element in my array, or I want to check if every element of my array is even or odd. The commonality here is I'm going to apply some processing, if statement, maybe another loop, maybe whatever complicated processing you can think of, but I'm going to apply this to every element in the array. Guess what? Counter control loop again. I equals 0, I lesser than my list.length, always I plus plus, and then do whatever you have to do with this item. So in this case here, I use system.print, so I'm going to display the first value, then the second value followed by a space, the third followed by a space, and so on and so forth. And I'm going to fill my line with all the values that are contained inside that array. What if I don't want to just, you know, read the value in each slot of the array, but I want to maybe modify it? No problem, same logic. Create your array or get it, you know, like we're going to see how to pass them as parameters to methods. So get an array from somewhere, counter control loop because you want to do something on every element of the array. From int I equal 1, I lesser than 5, I plus plus. What's going on here? That lesser than 5, that's bad. We should replace it by I lesser than values dot length. So avoid hard coding the size of arrays like that. Always use dot length, okay? Do what I said, don't do what I just did on this slide. Thank you. And then what about this I equal 1? Why do I start at 1? arrays start at 0, right? Well, let's take a look at what I'm trying to do inside. So for every element at index I want to change the value of that element. The new value will be the index plus the value that is stored in the previous element of the array. And this is where you guys are going to start, well, you guys, some of you at least, okay, are going to start making your first bugs with arrays. Because if I say, I'm going to look at every element, index I equals 0, next iteration I is 1, I is 2, I is 3, and so on and so forth, okay? The logic that I write in the body of my loop needs to be valid for any values of I, from 0, for example, to 4, if I have 5 elements. So let's check it. Let's check the beginning and let's check the end, because this is generally where things go wrong. When I is going to be equal to 4, when I'm at the end of the array, okay? Values index 4, well, that's the last element of my array, is assign the index 4 plus values index I minus 1. So 4 minus 1 is 3. So in my array, I'm going to assign to values index 4 the value 4 plus whatever was in values index I minus 1. Perfectly fine, okay? But what about the beginning? If I started at 0, what would happen? Values index I, which is 0. So values index 0, the first element of the array, is equal to 0, so far so good, plus values index 0 minus 1. 0 minus 1, so values index minus 1, array out of bound exception, your program crashes at runtime, okay? So because I want to go through my array, and what I want to do to my array is pretty much assign the index of a slot to that slot and add to it, the value of the previous slot, then I need to start at 1. When I start with 1, I'm going to say values index 1 equal 1 plus values index 1 minus 1, which is value index 0. That's the first element of the array, and that's going to work. But I never did anything to the element at index 0. So here it is. After the loop, values index 0 equal value index 1 plus value index 4. It's completely arbitrary what I decided to do here, okay? And it doesn't matter because I want you to learn the pattern. I want you to learn the pattern so that you may then apply it to any sort of new problem that you encounter. The pattern here is I want to do something on every element of my array. And the warning about that pattern is, watch out. Sometimes you want to take into consideration other values elsewhere in the array, and you are going to start doing what we call index arithmetics. So you are going to make arithmetic operation on the value of I to try to locate another element somewhere else in the array. And when you do so, you need to make sure that whatever formula you use with I makes sense for all of the iteration. Most of the time, you don't have to worry about the middle values for I. You just worry about what happens when I is the smallest in your iteration, what happens when it reaches the highest value. So that's where you start testing. That's where you start checking your code, okay? And then depending on what you're doing, sometimes you have to take into consideration other values. But for us in this class, if you do that, you're going to already protect yourself from 90% of the possible bugs. So that one, we're going to look at it together. I'm told that this is a problem in Introduction to Programming, okay? Unfortunately, I forgot if I had that problem when I was a student. It has been way too long. So it's up to you to tell me if you feel this is hard or not. Here's the job we are trying to do. I want to go through every element in my array. So this is a pattern we talk about. Okay, go through every element in the array, apply a certain processing. The processing I want to apply is whatever I need to do so that at the end, I've found the largest element in the array. That's what we want to do. So I want to write a loop that's going to explore all of my array elements. And I want another variable. I'm going to call it max. And when I'm done iterating over every element of the array, I want the value inside of max to be the largest value that I've seen in my entire array. Or I could switch that around and say, hey, I want the maximum, minimum of an array. This is a very classic problem, okay? So what I'm being told by colleagues, etc., teaching in the computer science track, etc., is that if I asked you today to do that without, first covering it, that would be a problem. Good. So that means that's a good example for us to focus on, dissect it, make sure you all understand what's going on. So the way that I introduce this example is I tell you it belongs to that pattern. I want to do something over every element. What do I want to do over every element in the array? Well, I want to take one element of the array, look at what I have in the max variable, and ask myself, are you bigger than the max that I have right now? If you're not bigger than the max I have right now, go away. Next element. Are you bigger? No, go away. Next element. And then finally, when I find an element in the array that is bigger than the value that I have currently in max, what do? I say max, go away. Now the new maximal value that I've encountered so far is that one. So I copy the value in max. And then I go to the next element. Are you bigger? No. Are you bigger? No. Are you bigger? Yes. Throw away max. Now use the max. Okay? That's it. So how do we write that in code? Again, we access element one by one. So I access this element here at index I, and I check if that element is larger than max, then max equal that element. That's exactly what I mimicked here, like juggling with my hands, okay? But there's a flaw to that. What is the initial value of max? So I could choose to initialize max to the smallest possible integer, knowing that the first value that I encounter in my array most likely is going to be bigger than that, so I'm going to do the switch around, okay? But another way to do that is to say, I want to initialize max to the first element of my list. So I make an assumption. I say, you know what? The first element of my list, this is the biggest element I have seen so far. And then my iteration starts at 1. So the element at index 0 is considered to be the max. And then my iteration starts at 1 and say, okay, let's forget about the first element of the array. Let's look at the second one. Are you bigger than my current max? Yes, no. Reassign accordingly. How many of you look at this and think, okay, I got it, it's trivial. I could have written it by myself. A few, okay? Okay, even if you're not too sure, it's already a good deal, okay? So, all right, 3 out of, I don't know how many we are in the room here, like maybe 30, something like that, I don't know. The others, that's a good target, this one, okay? Like I told you, the Java bad exercise, from last series, there's one of them, man, it's like way harder than the final. It's hard preparation for the final because it's harder than it's going to be. This, no, this is in line, okay? First time you encounter it, it seems wonky maybe, no problem. But don't let that discourage you, okay? Keep at it. This is your goal. You need to be able to read, by the time we're done with module 9, you need to be able to read this, not write it by yourself, from scratch, but read this and understand, be comfortable with the logic. Because the more comfortable you are with that logic, the easier it's going to be for you to tweak it and start like modifying it a little. For example, what if I want to have the 2 largest number in an array? Well, that would be a little bit more work. Okay, that one is a little bit more complicated. But I could say max 1 equals, by default, my list index 0. Max 2, the second largest, is equal to my list index 1. Okay, and let's say that I don't care if max 1 is actually the largest or max 2 is the second largest. I just want to keep the 2 largest values without order in max 1 and max 2. Then I would start my iteration here at 2, right? This is the logic, right? I skip the ones that I already looked at as being the max. Okay, so this is how we're going to stretch every single one of those patterns, every single one of those examples. Next one is there only because we went from the trivial to the not so trivial. And I want to illustrate again, how far we can stretch that pattern. When we were looking at this example here, modifying all the elements with the shenanigans here with values index I minus 1 here, this is the first time where I was doing something on every element of the array, and that something depended on the value of another element somewhere else in the array. That was the first time we did that, okay? one application of this, because this one is kind of arbitrary, it's kind of like, how do you come up with those examples? Well, one application that is a little bit more rational of this is, for example, if I have an array of values, and what I want to do is I want to shift the value. I want to rotate the values inside my array. Okay, so look at this diagram here. Let's say this is my array. So this is element at index 0 here on the left, then element index 1, 2, 3, blah, 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 up to whatever value n. Okay, so what I want to do is when I'm done iterating over my array, so it's still the pattern where we iterate over every element, I want to replace every element by the one that would come after it. So element index 0 here, I want to write inside of here the value of the next element. Copy this value here. Then I move to the next element. I want to copy in that second slot the value that is after it. So element at index 0 gets the value of element at index 1. Then I move to element index 1. Element index 1 gets the value of element index 2. I move to element index 2. Element index 2 gets the value of element index 3. I move to 3, and so on and so forth. Okay? So that pushes all the values in my array to the beginning of the array, right? So I squished that one. I lost it. Like whatever was in the first slot of the array got overwritten by whatever was in the second slot, and it's gone. Well, I'm going to have to be more careful than that. If I want to shift all the element one slot to the left, to the beginning of the array, that's okay. I lose the first one. But what I want to do is I want to rotate them. So the first element needs to go back and be copied at the end of the array over there. So the value inside of my list index 0 needs to, at the end, find its way to my list index n, the last valid index in the array. How do I do this? Okay, I need an array. Double temp is not my array. I still assume that I have my list. Do I even have it declared somewhere? No, I don't have it. So we are going to assume we have the same declaration than the previous slide, right? Double empty square bracket, my list equals new, blah, blah, blah. And then we fill the array with something. User data, like we learned to do in the previous slide, or random number, it doesn't matter. And then what I say here, my first step is I'm going to save in a variable named temp. So temp is just a double. I'm going to save the value of my list index 0, the one that would be crushed otherwise, when I shift all my values to the left. So I saved that value of my list index 0 inside the variable temp. Okay, and then what? Counter control loop, again, I start at 1 here. We're going to double check that. I lesser than my list.length I++. So I want to start iterating at index 1. That's the second element. Then go here, then go here, then go here, then go here. I start as a second element. Why? Because what I do in my code is, in the body of my loop, is my list index I minus 1. So when I start with I equal 1, 1 minus 1 is 0. So what I write here in the body of my loop is my list index 0 equals my list index 1. That's it. I did what this little arrow represents. I copied the value that is in the first element, index I equal 1, into the second element, the value that is in the second element, into the first element. And then I'm going to increment I, and I'm going to copy the values like this. When I'm done, when I reach the end, I copy the value in the last element into the before the last element. And then after the loop, I say that my list dot length minus 1. So that's the index of the last element, the one at the end over there, equal temp. That's the value that I saved. So I implemented that copy here pretty much, where I put the first element into the last. Okay. So arrays, in a way, as the first data structure that you are encountering. Okay, so we are kind of like doing the kind of stuff here that you are going to encounter when you take the data structure class. We are just doing a very, very simplified version because that's the first time for most of you that you encounter those concepts. So we're not going to go crazy with hash table and stuff like that, right? So arrays are kind of intuitive to understand. You saw vectors in K12, so that's not completely, a foreign land here. But what we are learning to do is we are learning the rules to deal with that data structure things like the index is what to be careful with. And then, sorry, we start applying that data structure to solve like little trick problems. Like I want to rotate my elements, I want to shift them, I want to shift them by 2 positions instead of just 1, blah, blah, blah. I want to shuffle the element. So here's the deal. When you study data structure, a lot of those basic tasks that you are going to learn to do, the first time you encounter them, it's like a puzzle. Okay, you don't know exactly what to do with a piece of the puzzle, like to unlock the loops or whatever. You are going to tinker around with that. You're going to learn how to solve one puzzle. Then you're going to go to a different puzzle, so learn to solve that one. After you have done that with a certain series of puzzles that represent, the basic stuff we can do, then the expectation on you is if I bombard you with a totally new problem, a new puzzle, then you need to be able to figure it out. Is it going to be like immediate? No, never. Okay. It's going to be taking some tinkering, trying, is this new puzzle similar to the other one that I learned, 6 months ago, etc. But when you go through that process, again, that's the difficult part of programming. But this is what we're trying to prepare you all along for. Okay, COP2512, 2513, COP4515, program design. The idea is by the time you get to data structure, you're good with syntax. You know how to troubleshoot a compilation error. You know how to find a bug in a program. But now, the programs that you're going to write, they are going to be clever, but not the bad kind of clever, that I showed you when people over abuse the syntax. No, the kind of clever which is like, wow, that's a neat little problem. I didn't know I could solve that, but somehow I managed. Okay. All right. We're going to wrap it up here for today. If you have questions, I'm not going anywhere, so please hang around. And next time we'll finish up with those basic patterns.